No, this is one of those USB SDR dongles. Those that's super cheap. I bought it years ago. I can't remember how much I paid for it. Maybe somewhere between $5 and $20, something like that. I've been doing the direct sampling mod to it. I know from somewhere from internet I read that the input impedance for that chip would be in the neighborhood of 3000 ohms, so 3 kilo ohms. And yeah, you need some kind of transformer to get it sensitive enough, and also some filtering so that you don't get all the crap from the HF into the chip. So I decided to build a simple LC network, so inductor and capacitor network, just to convert a low impedance to a high impedance. So we're getting 50 ohms in, and we're getting I think I've measured around I put in a 2.7 kilo ohm resistor there because that's what I found easily. I think in the neighborhood of 3 kilo ohm would be more in the neighborhood. I used a 10 mil drill and just put up 50 turns of that wire and call it good. I measured it with the spectrum analyzer that the input impedance for that 2.7 ohm resistor is in the neighborhood, like the SWR basically is in the neighborhood, like under 2 basically. And then I did the mod to the stick and basically adjusted get the gain just on the 20 meters, because that's what I'm heading on, 20 meters. I wouldn't say I don't need to be too exact with the turns and matching it to 50 ohms, because my antenna won't be 50 ohms. I'm still having that 5x8 antenna I'll be talking about on 11 meters, so yeah, that's where we are. So now I've been basically measuring the performance of this device, and I would say I didn't measure the direct sampling before I put this together. After all, nothing is soldered to place, it's just clips and wires just around another wire. So now what I'm gonna do is show you what the sensitivity of this device. If I get it to start up, did it tilt? Give me a minute. So here we go. I'm modulating 3 kHz signal on 14.2, and as we know, the frequency isn't exact on these things. It's one of those cheap ones, so I'm just looking to get it in the middle of the carrier. I can actually put off the here we go, off the carrier, that you can see that's only the carrier. And yeah, I'm listening on narrowband FM, and let me see, let's put some volume up here so you can hear it. In the minus 90 dBm, it's quite, you can just hear that the signal is there. At minus 85, you basically can hear that there, you probably could read that signal already. And at minus 80, I would say that's pretty clear. And of course, when you go up in the power even more, that the last squalls vanish. I'm using a 3 kHz test signal. because that's something I can relate to. That's something I can make a reference. If I take my handheld device on 2 meters, it should go down to around minus 120, 125, something like that, on 2 meters, 70 centimeters. But that's not all. I mean, with the 3 kilohertz signal. Of course, when you're taking the modulation away, you can hear much clearer that there is something. So the modulation is actually taking out the power of the signal. So that would be, we could say it's in the neighborhood of, let's put the 3 kilohertz there, in the neighborhood of 90 to 80, somewhere between 85 and 90. I would say, just for the reference, 90. Now if we listen at the signal, and now I'm gonna bypass my yeah, it's that one here. Now I'm gonna bypass the signal that's, the coil. So we still have the capacitor in here that does something to the SWRs. But let's start to put on some more power. We're getting something here. It's somewhere between 15 and, yeah, maybe 15 dB better with the coil adjustments. 15 to 20 dB better. Yeah, it's definitely not 15 dB. But I mean, yeah, it's definitely not 20 dB, but in the neighborhood of, can you see that? That would be 20 dB better. I mean, I'm sorry, 30 dB better. No, 27. Yeah, 20 dB better, yeah. I haven't slept too well last night, so sorry about my mumbling. But we could say it's in the neighborhood of 15 dB. Better reception on the specific band. It might change when I take out the adjustment altogether. And when we go out of the tuning band, it's because this coil capacitor thing works only on one specific band. So let's go to, let's say, 10 megahertz, and let's connect that back. And just for the sake of it, I want to check that it actually works still. Yeah, that was quite dead, so in the minus 90, yeah. So we're getting, well, maybe 10 to 20, 10 to 15 dB better performance with this mod. It's just some parts I put together. Let's go down to 10 megahertz just for the reference. So we're there. 10 megahertz. 10 megahertz set. And now we need some more power to even find the signal. It's right there. And why did I press that one? Narrowband FM. That makes the trick. Here we go, we're in the middle of the carrier. Yeah, that's already 5 dB. At least 5 dB was there. Going down to 7 megahertz. Here we go. 7 megahertz. 7. Some more power. Here we are. Just for the reference, let's adjust the frequency. Here we go. So we could safely say we're going around 10 dB with this setup. Let me just take off the wires, unwind the wires, and see if it still keeps the deal without the capacitors. And this might actually be better like this. Nah, it's not. It's pretty much the same. Let me do my so now I took the capacitor out. That wires goes to the pin, and this is the ground. It goes to the, I've just soldered to the USB some ground plane, and yeah, I think it was actually a little bit better with this mod. On 40 meters. But yeah, let me see that the camera sees what we're doing here. Here you can just hear someone's there. And clear. Yep. So let's go to 20 meters. Yeah, now the frequency is set. And oh. Yep. Let's adjust the power. Yeah, I would say it's around 15 dB better at least. Because we were somewhere here. If we just listen at the signal, somewhere the signal was around this strong with this mod on when it was in the circuit, and it was like down to minus 90. It's still not enough of attenuation to basically not see that it doesn't overload. It depends of what kind of antenna you have. So I'm gonna hook this up to the vectrum analyzer and show you what's going on. Now this is the stick at its own, connected to the network analyzer, and we're measuring the return loss. And as we can see, there is in the neighborhood of 120 megahertz, there is a spike there. This is when the unit is powered off. And when we connect it to the computer, let's see what happens. Oh, I lose the connection. Yeah, it definitely changed the curve a bit. just by powering it on. Will it change when I will launch the app? No, it doesn't care. At least with this modification. Let me put that one back on and show you what happens. Oh, the spam is from 300 kilohertz to 200 megahertz. Here we go. Now the circuit is in place. The dongle is powered off. We're still in a return loss stage. Let's take the marker. Let's do the minimum search. We are just at 15 hertz, the dip. Let me change the format to SWR, and we see a much better scale. So when the unit is turned off, we get a peak of resonance at around 14 to 15. Yeah, around 15 megahertz. One peak at the so nasty broadcast band area, and one peak at around 180 megahertz area. If I go higher in the frequency, let's say to 1 gig, it's quite spiky. Anyway, we are interested in the 20-meter band, and let's take the marker search, minimum search. We changed the scale to look at much smaller area. We get the peak down to 14.1. So it's changed a little bit when I've been figuring around with it. Just changing touching the coil and a little bit changing the setup, how it's on the table, it changes it. But when you plug it in to actually power on the chip, something magic happens. Or SWR jumps up. That's because the chip is powered and it has a different resistance in it. So now SWR is already 4 up here, so we might get few more decibels by tuning the circuit even more. Let's go up to the 1 gig again, and we see the spikes again. But that's basically how I did it. Tried few different coils. I did use actually a calculator, LC cap, the impedance matching online calculator, and then I used some online tool to give me to basically make some guesswork and put in some values to get a coil that's in the near of what I want, and then it's actually stressed out a little bit. The coil is actually stressed out a little bit, and now I lost the connection somewhere. So when I push it together, or actually even if I just put my hand on it, it will change. So this is really unscientific at the moment, because of all this metallic box and everything around here. I use this basically just because I happen to have it laying around. Here we go. Let's change the marker, minimum search. We're still up there in around 4 SWR, but that's something that you can still tune out. I think 20 meter is dead at this time of the day. It's already 9:30 in the evening, and I haven't slept too much this last night, so that's why I'm a little bit mumbling. But being basically up 20 hours now. Anyway, I could hook it up to the HF station and see what kind of crap we're getting in there outside of 20 meter band, because I don't think the 20 meter band works that well. That's basically one way to do it. Yeah, I think I'm gonna make another coil for my... oh, it's actually grounding it. My ground shielding doesn't... my insulator doesn't work very well. Yeah, I think I'm gonna hook it up and see how bad it actually is on the HF band. One moment.